recording, and I'll try to. Okay, seems fine.
Brilliant. Okay, right. That there, because you can't see it. Just my notes and reminders. So, just as a quick refresher about ECS. Now, ECS made up obviously of three key components: entities, components, and systems. Entities are an identifier, a number, if you will, that just uniquely identifies that entity, whether that's a tank, a projectile, a tree, or whatever. Can even be ethereal things. For example, pathing requests could become an entity and get an entity ID. So it really is pretty flexible in what it can be. And what you hang off an ID are components. Components are a data that represents a simple concept. So a good example that I use, which helps contrast with object-oriented programming, is if you've got a game where you can be a fighter or a wizard. In object-oriented programming, you probably have like a fighter class and a wizard class, for example. And in an entity component system, the data that represents a fighter could be in a fighter component, and the data that represents a wizard could be in a wizard component. Now, if you've got the situation where it's like, yeah, I could be a fighter, I could be a wizard, that's great. But what happens if you want to be a fighter wizard? A combination of the two. It's just such a powerful trope. In object-oriented programming, you have to. It's like, oh, we've got this fighter class, we've got this wizard class. This is going to get messy, and there are many ways that you can approach it, but none of them are particularly elegant. They're quite painful. But in an entity component system, you just hang the fighter component off your entity 22 or whatever. Say your character's entity 22. You just put the fighter component on that, and then you put the wizard component on that. It is now a fighter wizard. It now has the data for both. Haven't had to do anything amazing or clever. It is now both of those things. So that's pretty awesome. So components strictly don't have behavior. Now, obviously intrinsic behavior, like adding two numbers together and things like that, that's fine. But proper business logic and stuff like that, we don't put in a component. That's reserved for systems. So they're essentially a separate thing, if you will, and what that's responsible for is essentially iterating through components and processing those. So with systems contain all the logic. So to process all the fighters in the game, there'll be a fighter system, and it will go and do whatever the fighter needs done each frame, and then there'll be another system for wizards that will run through and do whatever wizards needs to do. And if you're a fighter wizard, well, both the systems will operate on your entity accordingly. Strictly speaking, with systems, they should not have state. So they should just be completely stateless, effectively just a collection of static functions. So that sort of in a nutshell is ECS. Now, with those restrictions in place, I can imagine you're probably already thinking that there's a number of situations that you can probably think of, which would be, well, how do you do this and how do you do that? And hopefully, as we explore this in a little bit more detail, a lot of that will become clear. A lot of those challenges, like how do you communicate between systems and stuff like that. I've done that in this experiment with the ECS, and I can show you how we would implement that in an ECS as we explore. So as I go through, if there's anything that doesn't quite make sense or you're not sure about, please just interrupt me, stop me, and get me to straighten out any uncertainties, because ideally for each next topic to make sense, you kind of need to be comfortable with what we've already talked about. So before I go on, is what I've talked about so far about an ECS system, does that make sense at this stage?
Yes, but I have a question. You said that ideally systems wouldn't have um, rules and sort of thing. So if you've got a system for resource management, how would you handle something like the metal maker ratio, for example, or the amount of metal extracted from a single max?
Oh, that's a very good example because that essentially that stuff is actually going to be covered by the ECS experiment because I was actually working with the resource system. The flow economy is the example in this particular case. So we'll be able to go into the detail of how that operates. And so keep that question in the back of your mind. And as I go through the flow economy, if it doesn't look like I've answered that question by going through, just pull me up and ask me about that.
Certainly, thank you.
What we'll say is that at this stage we've done a lot. I've done a lot with the ECS and cleared up a lot of things. This is by no means going to be the architecture is no means by final. We may discover as we include more and more systems, if we were to go ahead with this, that there may be a need to reevaluate some of what we've done and adapt and change accordingly. So this is just what has come about, and the architecture is designed to address all the problems that we've seen and thought ahead to the sort of problems that we've seen, and also research and that. But that doesn't necessarily mean that there won't be challenges that will need some of this stuff to be reevaluated in some fashion. As an example of companies that have used an ECS, Overwatch from Blizzard actually runs on an ECS. And they've done I think it's the game conference tour. I'm trying to remember what it's called now off the top of my head. I should know.
GDC?
Yes, that's it. Oh man, how can I be a game developer and not know GDC? But yeah, they had a thing on there. But what you'll see is there's going to be differences between what I do here and what they do there. And I'll just point out that the big difference between what they're doing and what I'm doing is scale. In Overwatch, they only have to deal with
A dozen characters.
a dozen characters, 100 or so projectiles. So they've got something that looks more like they had an object-orientated idea and they've just converted it straight into ECS. That's fine for what they do. And in some ways, it works quite well for what they do. But for Spring, we're talking about trying for 10,000 units, trying for 100,000 projectiles or particles. We need to do things slightly differently to get the economy of scale. And this is what ECS helps us with, because by laying out things in components in the way that we do, we are going to optimize memory management. So the von Neumann architecture, no matter how many CPUs you've got, you're still going through that single bus to system memory, and often it's system memory that determines the speed in which your game runs rather than the CPUs, and certainly limits how far you can push multi-threading as well. So for example, our pathfinding system tends to top out at about 4 threads, and that's just because it hits a memory bandwidth. You add more threads, you're not going to get much more performance because just the memory subsystem cannot supply all the threads with the data.
All right, the cache locality is so bad on that?
Well, you only have so much cache, and the pathfinding uses, can span tens of megabytes, if not into hundreds of megabytes. So that's, if you can keep it all in the cache, then that obviously helps. But again, level 3 to level 2 cache, there's potential bandwidth limitations there as well, because that level 3 cache has to serve all the level 2 caches simultaneously. But when you get to level 2 to level 1 caches, and that it becomes less of an issue in terms of scalability. But yeah, so rather than get into all that, I should really have lots of lovely diagrams to show you so you don't get bored. But what we'll do is I'll now explore the code here, go over it sort of top level and start drilling down into bits, and we can talk about it as we go. And if people ask interesting questions, it might be a good diversion to that, but I'll try and keep this into some sort of coherent form. So what I'm going to try and do is approach this in a way to help you visualize what the impact on the engine is going to be, so that we can decide whether this is a architecture we want to continue with. Now, to keep things as clean as possible, I have kept everything new ECS code as much as possible under sim ECS. Probably some of that stuff probably should be moved into system into the future, because we would obviously want rendering to be able to take advantage of ECS if we go this way, to help with loading up objects and things much more much more quickly, and so on and so forth. So at the top level, the most important header is the ECS main header. The first challenge I had with bringing entity in, as you can see from that comment, Lua breaks entity, because it defines macros that get used as word. Cast and registry are, strange enough, words that get used in templates in entity. Entity is just effectively a set of headers full of templates. It is exceptionally well coded from the perspective of how it uses templates, which makes it incredibly tricky to unravel how it works under the scenes. So I've set up this header. So if we wanted to use entity, you include this header, not the entity header directly, because this has the protections in place for keeping things under control, because I have to remove those references, do the entity stuff, and then I have to put the references back in. So if we change Lua in the future, we'll have to remember that those hopefully won't need to ever be changed, but those are the current state of those macros, and I'll put them back in.
Yeah, makes sense.
So where possible, I try to put things into appropriate namespaces and classes. So even though things may not need classes, I still try and put them into some sort of class because it acts as a namespace. So in case of the registry, we have the registry defined there. There's a CPP file just to define that there's one registry. We can have multiple registries. It's just try to have as few as possible generally, because that makes it easier to work with the code. But if in the future we were to use this, we could, for example, have a registry for rendering and a registry for simulation. And there's a possibility there, for example, that if we could create, that could give us a stepping stone to creating a separation, if you will, between a rendering, a set of threads dedicated to rendering and a set of threads dedicated to simulation. And then because of the way that the registry is so optimized memory-wise, it's not a big deal, or anywhere near as much of a big deal, transferring the entire registry from, essentially copying it from time to time, i.e. each time simulation completes. So you could have essentially a lockless approach of basically providing the next sim state to the rendering thread, and the rendering thread can use that, and the simulation thread could just get on with updating its state as it sees fit. But that's kind of like way into the future if we did decide to do that. But that's one of the nice things. This helps migrators to do that, because all the data is logically kept in the same area. And as you see with, I'm going to show save load later, how easy it is just to basically take the entire registry and dump it somewhere or load it back. In this header, I just have a few helper templates. I may need to move those to a more logical location, but we don't need to explore those too much. We'll see those being used. The other top level header. Now, this is an interesting thing from an architectural perspective, and this is going to be one of the areas of potential impact. The way that we have to iterate through entities and the way that components are all arrayed, components, for performance reasons, they're all compressed into a dense array. and not all entities are going to have all components. So in any given index into component array isn't necessarily going to relate to the same entity. The system knows how to track where everything is, and it's got a pretty fast way of doing it by using sparse arrays. Fastest way to obviously iterate through data is just to say, give me a list of components and I just process them, because then you don't care about order, you just process those as you're given them. But if you care about what entity 22's got, you may find it's in different places in each component array. So if you've got your position component, it might be the first thing in there. If you've got a vector, like a velocity component, it might be the last thing in there for whatever reason. So that affects how we go through loops. Now, the reason I bring this up is because in Spring we have an optimization called slow update, and what that does is it goes through a subset of units every frame. So over 15 frames, we go over all the units, for example. If there's 150 units, every frame we're doing 10 units. And for slow operating things, that's fine. In Entity, we can't do that because we've got so many arrays and everything's in so many different places. If you remove an entity in between frames or a unit, let's say you delete a unit, finally, so it's been destroyed, we don't need it anymore, you remove it. Any list that's basically tracking between frames, this slow update, it needs to know where that entity was in the list because it needs to update its pointers accordingly so that it doesn't, for example, double count or suddenly miss a unit. So when you've only got one list, like a list of units, like we have in Spring, that's fine. You're just tracking one array. And that's like a mega, that's if you've got mega objects where everything's contained in them. In Entity, we're going to have hundreds of these little lists. You do not want to have to go through hundreds of lists every time you delete an entity to say, well, this one, no, I don't need to adjust the pointer. This one I do need to adjust, and so on and so forth. It's just, no, don't do it. But that's fine because Entity is so fast iterating through components. We're talking, in one example, I had over 22 times faster than the Spring equivalent implementation. So we could get away with just going through every list, every frame completely if we wanted to. But for things that don't need to run so fast, why run that every single sim tick? So what I've done is I've set up this idea that we can space out the updates at intervals. So here we've got what I call real time, where every frame, that system will be updating every single frame. For things like physics, that has to happen. Then we've got fast update, which is just every third frame, i.e. running at 10 Hertz, and the flow economy system runs at that rate. And then you've got the slow update rate, which is 15 frames or 2 Hertz. Now, all of that is nicely divisible by 15 because 15 is the magic number in Spring. It's how it tracks its performance on half-second intervals and stuff like that. So I've just picked numbers that work with it and give us flexibility. So every system will tick over at one of these three rates. And for every system that I set up with the tick rates, so I've actually configured each one, as you can see here, to have a particular update rate. These ones are all running on the fast because they're all connected to the flow economy. To spread out the load across frames, I also choose which pick they're going to run on. So you can spread out different systems to run on different frames, even though they're ticking like 10 Hertz or something, so that we're not overloading one frame too heavily in relation to the others. Obviously, may not be necessarily a perfect solution, but then again, the slow update wasn't a perfect solution because that had bumps and things. But this is at least an attempt. As I know, Beher, if you had concerns about, obviously, we need to try and stabilize the amount of time that sim takes on each tick as much as possible. So this is
sim frame
configurable.
variance is actually a surprisingly big issue while we're on a shared sim and draw thread, and it makes things really difficult to keep smooth and make things look better under the hood. But so what you're saying is that this won't, if there's a tick, let's say you have a slow tick rate for 15, for every 15 frames, that means that it's going to update the entire thing every 15 and not do a 1/15th subset per frame.
That's right. Yeah.
Okay.
That's just an unfortunate consequence. But in defense of that, you're going to see that the systems are very small. So what you're looking at there is things associated very closely with the flow economy system. We've got five things listed there, but because everything's broken down a lot, you can spread it out.
I'm wondering if you could put the slow stuff on different congruency levels.
So in terms of how clever we're going at the moment, I've just kept something that's simple and easy to configure. So if we, for example, had a target balance load scenario, we could say, oh, these things are a bit heavy here or there, and we could just adjust the numbers. There's nothing to say we couldn't change, have a system that monitors performance and could actually start rebalancing what tick rates and things, which frame certain things will run on, and that, as long as the systems are sufficiently agnostic to what's happening around them, and where possible, I'm trying to do that a system doesn't care about the world around it.
Lines 25 through 29 do exactly this. It gives an offset.
Absolutely. So what I'll do is I'll open up an example system so we can show you that closely on update. So here you go. So we take the frame num, we modulus that against the build rate, the tick rate, essentially. So this ticks over once every 3 frames, and then we check whether it's the appropriate frame. So that could be 0, 1, or 2. But I've chosen 1 for the build system. So it'll update every third frame, but it's offset by 1. The flow economy system, its ticks on 0. So it'll update every third frame, but when the modulus is 0. So this will always be updating on a different frame to the build system. And that's one way we can spread out the workload. It's simple. It gives us something that we can start off with. And I've kept the values that I'm using all in one header. I was tempted to split these out and keep them with the systems, but I think that the priority is being able to see the big picture and go, right, well, I need to balance these values, and you need to see what you're working with. And so therefore you need them all kept together. If they're all in different files, you can't do that easily. So I've kept them all together here. Let's have a look at some I'm just trying to think. Let's have some look at some components examples. So let's start with the flow economy components. So for anything that wants, so some of the examples here. So anything that wants to add a resource, this is a resource add component. It's just a simple struct. Well, it's not a simple struct because it's derived from a resource pack, which is a existing Spring class, but its purpose is to hold the resources for their, we normally create a struct with a name. Because of the way templates work, you need unique names. So I couldn't, for example, say, well, I just need a float. So I can't just, just say, oh, this component is a float of this name. It has to be based on types, because that's the way templates work. So I've got a resource add component, resource use component. As you can see, they're actually quite small. If I just jump to the resource pack, in this case, I've now updated this so it actually supports 4 resources in there. And as you can see, I'm now using Intel intrinsics. So we're using SSE. If you set resources max to 4, we're now using SSE. So that can basically work with chunks of 4 floats at once, which is quite cool. So people were requesting more resources to be supported at once by the Spring engine.
Very sensible, and makes use of SSE. So what's there not to like about that?
Absolutely. So there's if you look through it, I've done it like this. Maybe you guys won't like. It's a constant expression, so it just all resolves down during compile time. So I keep this. This is good in case you want to change the number of resources without breaking the engine. But at the same time, it also acts as a good documentation of what the hell that's doing. For me, I can read that and understand what that's doing. But for someone who's not familiar with intro intrinsics, they can at least see that and go, oh, right, I see what it's doing. It's effectively doing the exact same thing, but you can see there. So so all our components are structs. You've got what I call like tag components, which are just empty. ENTT has an optimization where it minimizes the amount of space they take up if you have an empty component. And I use these to build lists of things to process. So if I want to tag something as a particular, in this case, if I want to tag something as an economy task, so this entity is an economy task, I can tag that and look for that in the entity system. You'll see that used in effectively a bit later on. And I've built a system where we can simplify the creation of components that are just one value. So in this case, build rate. So that is constructed as just a simple construct with a basic component type. That stuff's just in there just because you can have something that's non-trivial and it will still work. But essentially, if you've got a struct that's just got a float in it, then all we have to do now is just alias component float. There is an advantage of doing that as well, because I have things set up so that will be automatically saved properly. There's some stuff here about serialization, but I think I'll come back to that, because what we want to do is, like, you've seen some stuff about components. Let's put that into context of using it in a system. So to try and cement what we've got, I'm just trying to think. Here's a good example. This might be a bit more familiar with people. Some of these components. So we have a unit ID. Everyone knows what unit IDs are. We have the team number. We have a reference to the unit definition. Each of these are components. Each line here is a component. And generally, the policy that I've used is to keep components as small as possible. The reason being is when you're iterating over 10,000 things, every byte that you're not using in that loop is multiplied by 10,000 times in your cache as you're working through the cache. effectively it's wasted memory bandwidth. For things where you're only dealing with 100 things, you can have bigger, more complex components, fine. But when we're dealing with large scale things, you want to minimize the amount of wastage as possible, so that every system pulls out only what it needs and nothing more. So I keep these components as small as possible. Likewise, I keep the systems as small as possible. So these are just effectively structs. So let's look at systems. So let's try looking at the flow economy system. So what happens is that the systems, each frame, I trigger a call to update for every system that gets registered. And that's done during initialization. So we've got an initialization function. So every system needs to have an initialization where it will register itself for, let's have a look. Create system components, get system component, sets it up on destroy. Oh, here we go. System utilities on update. So this is using some built-in features of ENTT. With ENTT, you can set up list, publish, subscribe style systems built into ENTT, and I'm taking advantage of that. So what I'm doing is I'm subscribing to when the system update, when the engine calls on update, I'm connecting the update function of this flow economy system to it. So each frame, it gets called because the engine will call on update. So if I don't register that because for some reason someone's decided they don't want to use my new flashy flow economy system, I don't register it. It won't run now. No checks are done on it. It's just boop, not running. So that gives us some flexibility in loading systems or not loading systems according to what the game needs, or mod rules that are set up from the lobby and stuff like that. So you guys may, so this is very interesting. So when I said that systems cannot have state, you might think, well, what happens if there is something that's like, you know, global? It doesn't belong it doesn't belong in any units or anything like that. It would normally sit with the system, but how do we record that? And we use, so I've set up a utility for creating a entity, and that's purpose is to hold all global data. And in what we got here is we create a component, an instance of a component that's going to hold the data for this system. Now, by putting it in a component like this, anyone anywhere can query it without caring what, you know, about the code for the system. So they don't ever have to include the flow system in their code. They just need to include what's necessary to get access to the flow economy system component. And they can make a call to this, a get system component and the flow economy component. I'll just go to the definition of it to show you what it looks like. And that's the component there. It only holds one value because there's only one value that I need, the economy multiplier, which is sort of calibrated according to the engine tick rate and so on and so forth. This is an optimization that tells ENTT that when you set up the memory for this type of component, you only ever need to allocate space for one of these, because there's only ever going to be one of these. Normally, ENTT, for performance reasons, will allocate 1,000 space for 1,000 of that component. Obviously, I don't need 1,000 of these if I'm only going to use one, so I just politely tell it, just give me. But if I was to create another one, it would then allocate another page, and so on and so forth. It's just the page size of one, but I'm just careful to use only one. So in here, I get the system component, and I have to store that. So we can see that this is I get the reference to it, and then I can set the economy multiplier according to various parameters. And then that's brilliant. That component has now been modified. That line, you can monitor what happens to components in the registry. So you can request that if a component gets created or if a component gets destroyed, I want you to run a little function. So this is quite helpful for if recording economy jobs. I'll show you a bit later about how I do that and how this helps with that. There's another system that I use where if you use some economy, there's a whole load of components you're going to need so that I can show on the screen when you're building something in bar, you know, you've got that rate of how much energy you're using, how much metal you're making and stuff like that. That all has to be individually tracked and monitored by several components. Well, I can use the on create on destroy to track when a unit's actually got something that needs to be tracked like that, and then put the appropriate components on it. Otherwise, the code would get pretty convoluted trying to associate. It's like, well, when you've got this component, you've got to have these other ones as well. So flow economy. So just to show you how it works in bar at the moment, or in the engine at the moment. Every unit gets called individually in the Spring engine, and essentially it runs through this code where it just manually does all the various checks of all the parameters of whether you're adding whether you've got it set up to add metal, conditional add metals, metal making, metal extraction is here, you know, upkeep costs, wind. It's all done here, and it's reaching out to memory all in random places all the time. Not a huge amount of code, that, but then it calls out to all these various functions that do all this other stuff, and then starts disappearing into a rabbit hole. Now in the flow economy system, I'm going to jump to update. When it runs, this is quite a cool thing. I can set up timers for each system. Only run once per frame, so it'd be an interesting way of tracking performance against different systems. So in here, the flow economy system is a little bit more complicated because it has to handle proration for you. This is probably an example of one of the more complicated systems. So I try to keep the update relatively simple as a function, and it just calls out to the various jobs that need to be done in there, and it should be focused. These things probably should be split out into a separate component. I probably will do, because you'll see in a bit. So let's have a look at full economy draw. So this is entity in action. So in entities, what I'm doing here is I'm actually requesting a view, or this particular type of view is called a group, into data, and I'm asking for the resource usage component, and I'm asking for the team component as well, because in order to record resource usage request, I need to know what the team is, and I need to know what the resources are that we're using. So every entity that's got a resource use component attached to it is going to come up, provided it's also got a team. So as long as it's got those two things, it's going to come up in the group. And now I can iterate through that group, and essentially you iterate through the entities. So the group says, well, these are all the entities that met that criteria that have got all this stuff. And then for each of the entities, I have to pull out the component. So get me the resource use component, get me the team component. And if it's a single value component, i.e. it only has one value, I have this convention that that the field in there is in the struct is called value. So it's always called value, because that just makes things so much simpler to work with. So I pull them into local variables. Well, they'll get optimized out anyway. And then I do my calculation here where I call the team handler. That's just standard Spring code at the moment. Could be turned into appropriate components and whatnot. I pull out the usage and then I do the calculation. So it runs through very quickly and adds up all the usage that we need for this cycle. Are there any sort of questions so far about what we've seen so far?
No, it's a really good explanation, and I'm following along nicely.
I
have one, but I'm pretty sure you're going to get to it later on. That's actually a more specific one of how do you handle entities interacting with other entities?
Right. Okay. That's a very good question. So entities. Yeah. So what will be I'll try and find some code where we do actually. Yes, there is some code where we definitely do that. And that is in the so we'll be doing that with economy tasks. And what we're going to see there is, as you probably noticed here with resource usage, if we were to look at unit, you'll notice that there are many different conditions for resource usage here. Many conditions for resource usage. However, in the flow economy, you'll notice that that's just one component. And you can only have, for any given type of component, it can only be attached once to an entity. So what I do is, if, for example, you have a commander, and I'm just trying to think of the command, is the commander the right example? The commander can produce resources, and it can use resources. So I think there's other cases. There are cases where multiple causes of resource use is possible. But what I do is I create what we call an entity task. An economy task. And that's a separate entity that will be connected to that unit. This economy system has...
So there's like a very specific use case just to help everyone visualize it. Let's take, for example, aircraft carriers. Mm-hmm. Aircraft carriers, they can repair aircraft, and which can cost energy if the game so decides. I think ZK and their repair costs energy. It can also build anti-nukes, and it also has a radar. Now, this is actually a bug in the current engine. Not many people realize this, but for everything like jammers and radar and things like that take energy to work, but they don't actually produce any because that has been removed. They don't actually turn off when there's no energy. So, for example, if your energy's stalling, you literally don't have enough energy to run your jammers, they'll still run completely fine. Yeah, I'm pretty sure you noticed this at some point.
Oh, yes, absolutely. That is actually a good example. Yes. So for things like perimeters eyes and stuff like that, they have the energy drain that's caused by the cloak effect, but they also, for some reason, also have a permanent energy drain. that could be turned off. It's 3 units a second. So even if they're deactivated, they are still draining. They're still draining resources. Quite funny. But we could represent that by creating 2 economy task entities, attaching a resource usage to each of those, and then we can set up appropriate components via a doubly linked list, which I'll show later, that basically links them back to the entity that is responsible for those entities. So but this system doesn't care about that. All it does is say, just give me the resource use entities with resource use. It doesn't care whether it's a unit, a weapon, an economy system. It just really does not care or know that you could attach this resource use and team ID to anything you want in the game, whether it's a weapon, a projectile, a building, a tree, if you really wanted to, and this economy system will pick it all up and it will process it. That's a level of flexibility it's quite difficult to get in an object-oriented system. Let's have a look here. Update all teams economy. Right, that's running through all the teams. So this is kind of like a meat of the economy the economy task. So there's some setup that happens. So we pull out the team, current team. Yeah, okay. So we're updating some data here, and set up. This is it's not pulling a lot for that, which is fine. So it does some calculations. So the purpose of this is to work out the proration rates. And the code is simplified a lot because I've put a lot of clever code into the resource packs themselves. So that you can do things, sort of the divides. You can do a min now on that. So you can take supply and demand, get a ratio, and apply that against the max proration rates to get derived proration rates. The idea is if you're pulling 100 energy, but you're only producing 50 energy, the proration rate will come out at 0.5. So the idea is all the build jobs and everything, they're going to be told in a moment that you've got this much resource and this is your proration rate. So if it's a 50%, you're only allowed to make 50% progress. So updating team information, there's my debug. So that's the update of the economy. So that's the top level. So for each team, I'm setting up the details about how it needs to prorate. It's worked out its resources. So we're now going to allocate the resources. So what we do now is we run through again everything that's got a resource use and a team. And we say, right, okay. We pull up the details from the team to get the proration rate here. So the idea is that we're going to work out of the resources you're using, what are you going to get out of the available resources? So there's a resources, there we go, allocated unused resource component. It holds 2 values. I'll just jump to it quickly. It has the resources that have been allocated and a proration rate. So what we'll see later is that the build system will look at this and go, what's my proration rate? 50. Okay, I can only make 50% progress. But there'll be a really neat thing it can do as well, where it can go, well, I've just finished the job, but I only needed to use 20% of that. It will be able to update that with, well, I only used 20%, so 80%'s left. It will delete this component, and because the flow economy system's actually watching that. When you delete when you delete this component, it takes a look to see if you've left anything in the tank, so to speak, and it will put it back into the team's resources so that you can use it in the next tick. So no resources are wasted there. But yeah, this is the example of setting up the economy. So that was the use request multiplied by proration rate, multiplied by rate, the tick rate. So that tells you how many resources have been allocated. That's the proration rate. Because if you've got 4 resources, they're all at different rates. So basically, we use a function here to select the proration rate that's the smallest, because that's going to limit you more than anything. So if energy is at 80% and metal is at 20%, well, your progress can only be 20% if you rely on both of them. So it doesn't matter if energy is at 80%, because you can only use 20% of it because the metal's your constraining factor. And then it just updates the allocation there so we can track that in the numbers when we're reporting on the big screen to say this is what's actually being used. So that's just gone through and it's allocated the resources now to the components, to all the entities. Sorry. See, apply teams economy. So we run through the active teams and apply resource flow. Let me just double check that one. Oh, right. Okay. Yeah. So this, is that used? Res current. Yeah. So if you've got, I remind myself, this is storage loss rate. Maybe I should put comment in and explain what the hell that is. There's a note to myself. Res current use, max use. Oh yeah, that's to prevent overflows. So that we don't magically end up creating crazy numbers that are actually bigger than what they're supposed to be. My resource flow. This would be to. Oh right, yes, because it's the. Oh, I see. Yes, it's the accumulated order. That's it. That's right. So when I was adding up all the usage and from all the demand and that, I actually build a single request that I send to the team to say, this is what you need to do to your economy. This is how much is being taken out, because all of we've done all that allocation, but it hasn't affected the bottom line of the team yet. So basically, I just do that. That's what that's doing. It's just applying the usage. Go pop. There you go. I've used 800 out of 1,000 units. There you go. You've got 200 left. So anything that's not using the flow economy system, there's 200 in the tank for you to use. The flow economy system has taken what it needs and it's done it in one call, rather than the 200 calls that it would be going through every single unit, updating all those values needlessly. This bit, which is I'm going to split out into a separate system. These are the things for like commanders, solar panels, and stuff like that. These functions actually go through and actually apply what we call the passive economy. So if you're generating resources, it sorts all this out in terms of because what it's got to go through says, well, allocated resources. Yeah, this is the, we have to track resource usage. So when you click on say like a metal extractor, it uses energy. Obviously, we've got to keep track of the energy that it's using, and we've got a resource current usage component, which each tick we have to make sure that whatever it's been allocated, so right, that's what it's using. So we've got these jobs for simple what we call passive economy tasks that don't impact the rest of the state of the game. So metal extractors, solar panels, wind generators and so on and so forth get picked up by this. And there we go, there's the reason. So this is a more complicated example of a grouping. So yes, so what we see here, you see the use of two groups here. This is a clever little optimization about the way I'm using the flow economy system. So some things like a metal extractor add resources and use resources at the same time. Some things like a solar panel only add resources, they don't use resources. So as an optimization, I can tell ENTT, can you, when I'm using these, when I'm putting these components into the system, can you sort it out so that any entities that have got both these, add and use resources, can these components be grouped so they're all in order with each other? So what ENTT will do is that if you've got an add and a use component, those two component lists are now synced up. So it's incredibly efficient to run through those, because if you run through them in order, they're in the same order. But it's also possible that, as I said, that some things can use resources but not add, or add resources but not use. So they go to the ends of the list because they're not keyed or ordered to anything. So there's this optimization where I can say, right, I want to walk through everything that just uses resources, doesn't add resources, just uses resources. And to do that, I have to request the group that does everything and the group that just does the one thing I want. And then I take the difference in size, and then I can just iterate through, because ENTT runs through lists backwards for various reasons. So I can basically walk that list by comparing the length of the two groups and say, well, I know exactly how many of these things only have a use. So I'll walk through that group and do that specific bit, because the next thing I can call is a function that says, right, now give me everything that does both of those. And because the cache and where the CPU is pointing to for memory, it just continues down. So it just flows through the cache and takes advantage of prefetch by doing that. And as you can see, the logic for that I've got to apply if you've got add and use is different to if you've just got add, and it's different to if you've got use. So they get split out. One thing that you will see a lot of in ECS is a lot of this setup. As you see here, this is a good example. I'm pulling components out in the loop and I'm putting them in local identifiers. And this will happen a lot, because as you can see, this is not a short string, and I don't really want to be writing that out in the middle of logic. It will make the logic harder to follow. So, I'd rather use team ID. It's easier to follow. Reference to team, that's so much easier to follow. So resource add. Allocated resources is a good example because it gets used multiple places here. That's so much easier to follow than trying to write that in various places. Now, the consequence of that is I'm obviously adding more lines of code, because in a object-oriented system, if I was in a class, my thing would be called team ID anyway. My field would be called owner anyway. So it does mean that functions based on ECS code will be naturally longer for the same amount of logic, because you need to pull out the components. But you could probably consider that a partial advantage, because programmers have a natural tendency to make their functions technically too big anyway. They tend to go for like a page or maybe a page and a half or something like that. There's a natural tolerance to how big the programmers tend to make their functions, I find. And no matter the logic inside, it always tends to get to that like page and a half, which is strictly probably too big for 95% of the cases of functions anyway. So this will naturally mean that they will condense their logic, so that it will be split out in more functions, which is what's supposed to happen, really. So if a portion of your length allowance is taken up by this, so it limits the amount of logic you're going to put into an excessively long function, you're going to be naturally inclined to break it up more, which is good for readability and maintainability naturally. So there's a certain little sneaky advantage, I suppose, in that being the case. But obviously, you're going to see this a lot. You're going to see this a lot with ECS. You might see that as a little bit of a downside if you want like nice, short, really short functions. It's going to be harder to see those.
I have a question about something a bit different.
Sure.
So definitely I see all the arguments about like the using group and whatever is in the template parameter there. It's going to be like a single list, right?
Yes.
That you can kind of quickly go through. But what is really the structure? And here maybe it's probably like summary ENTT documentation, but what is the structure of pulling the other components for those selects, right? So sure, you're going quickly through the resource add and resource use, but then you need to pull team, owning entity, all those other things that can be in entirely different places in memory, right?
Right.
So you're going to iterate over all those things, all those lists like multiple times, and if each of those lists you're going to also pull those additional things, right? So like, from cache preference, like of course the first list is fine, but like all the others, yeah.
Yeah, that's a very good point. Yes, so in this case, everything in these gets, they're not ordered, they're not sorted, they're in arbitrary places of memory. So yes, you're right. It's going to get more random in its access. It's going to be less efficient. Obviously, it's like, well, that's not brilliant. But what the argument from Entity is that these components that we're reaching out to, like team, if you've got, let's say, 200 entities and they've all got a team associated with them, all those if we're iterating through, let's say, only 50 entities are going to be picked up by this group, right? All these team IDs and that, they're all compressed in the same area of memory as much as possible. So when you work with caches, you have to pull in 64 bytes into a cache line. Even if you request 1 byte, the CPU has to load 64 bytes into memory in order for you to access that one. Now, if the memory is heavily compressed as much as possible, in 64 bytes, you can store 16 entities worth of team data. So there's all these various cache lines. Now, if we're pulling a reasonable enough portion of those team entities, okay, it's not necessarily in order, but they will remain. Any cache page that we touch is very likely to remain in cache memory. And any time that we ask for an entity that was sufficiently close enough to any other entity we've already asked, it will be in cache. So as we go through more and more entities, the number of cache misses drops. And this results in better performance than in an object-oriented situation, because in a unit in object-oriented programming, the space between each instance of that team ID is going to be, several K at least, spaced out. So if you pull out an entity, the team ID for entity 22, it doesn't matter which order you do all the teams in or whatever you ask, you're always going to get a cache miss in C++ because no cache is going to have more than one team ID in it. But at least with entity, because they're all compressed and you've got 16 team IDs in that cache page, you're quite likely, as you go through more and more of these entities, you're going to start hitting the cache more and more often. And that's where you get that's why that still remains more performant than object-oriented programming. But you are right, that is it's kind of the worst case scenario for an ECS. What you pointed out there is that get style is the worst case scenario for an entity system. But what we have to do is we just have to try and minimize it.
Makes sense to kind of make sure that those lists are as short as possible, and especially the worst case scenario will be if you have, let's say, a very long list on the group and then also a very long list that you need to intersect on the right side that might be like entirely not prepared, not aligned. And let's say if your list on the left side, right, is in some order, and then you have a huge list on the right side that's different order, and then you are, let's say, having those very small portion of the code, each of them iterating multiple times over the list on the left side, and then trying to access stuff on the right side, like accessing stuff on the left side is going to have a lot of cache misses probably. Maybe not in L3 or somewhere, but at least on the lower level. So it's still kind of, there is some, it's not just you can just throw whatever code you want at it. You still need to kind of think about what are you going to do exactly in each of those loops.
Absolutely, yes. That's the key point that and very important about ECS is that you one of the reasons that for me, ECS actually takes longer to program because you really do need to sit down and, as you say that, think about what are you doing, and really think about it before you do it. It gets easier as you program more and more often, but I still find that programming ECS feels slower than object-oriented programming. But then I've been object-oriented programming for over 20 years or something. So and entity I've been using for 3-4 months. So that might be a factor in it. But yes, you do have to think carefully about what are you working with here. But I have seen people do games with entity where they use something called a registry view rather than group. So if I do view there, view is very similar to a group, but the key difference is everything in that view is treated like this. So there's nothing that's particularly ordered. And those games still get pretty reasonable performance that is still better than they would have got from object-oriented programming. But obviously it's not ideal. The reason I don't use groups extensively, I have all this stuff in here, is because there's a lot of very strict rules about using groups. You want to, so much so that you have to think about where are your hot paths in code and create the groups to support those if you can, because you can't put groups everywhere. It creates a number of restrictions. and you do have to think very, very carefully about those. Whereas views, you can just use views as you see fit. You can be a lot more carefree with those, but you just accept that you don't get the performance level from those to the same degree as you get with a group. So the thing with entity is if you're working completely within a group, just a group, you have an entity system that is the fastest entity system possible on the planet. It is faster than anything that Unity could achieve, because Unity is an archetype-based ECS system. It cannot, if you are just working with this bit, not this bit, if you're just working with this bit, there is no faster ECS system available than doing that. But this bit, this is slower, and it tends to be a bit slower than the way Unity does things. But you know, you got your balances here. So yeah, God, sorry, this is dragging on a bit. Okay, so
it's all very good. Thanks. I think like one question would be if then it doesn't make sense to make those functions actually a bit bigger to reduce the number you are going to iterate through for this stuff. So let's say if you were to, have this process portable economy and stuff like this, and instead of kind of having very small portions of the code that each of them is doing those iterations and pulling some random stuff, to have them kind of still condensed, but like basically do more in the single function.
Right. Okay. So you're probably referring to the fact of what I'm doing here and then here. So the difference here is this is a special optimization I'm using in Entity. It's specific to Entity, where I'm deliberately cropping. By building a group like that, it doesn't do very much in memory. It's just basically giving me a hand. It's like giving me a handle. It's only when you start doing this, you start touching the memory. So groups are very, very light to create. So they're negligible impact on performance. You couldn't even measure it. So creating groups is a non-issue here.
So this I think I understand. You are basically want to only iterate for the resource adds that don't have resource uses.
Precisely.
Right? Yeah,
that goes
that's
through.
Fine. That's fine.
Yeah.
But like I think like in this portion of the code, it's not a question, but kind of as people as writing more code.
Right. Okay.
Something they need to kind of keep in mind that like actually having plenty of small functions, each of them iterating is not the good pattern, probably.
So, right. Okay. Yeah. So with this, by keeping your components small and your systems small and focused, you will actually mitigate a lot of that, because this system is about the only system that's going to iterate through these components. What you'll find is that for key components like this, which are the loop control, if you will, only one system's going to do it. These are like supporting components you've got to reach out to anyway. And what this loop does, no, you're not going to want to combine that with any other loop. So if you build but you're right, so you've got to build your systems with the right responsibility. If you build it with the wrong level of responsibility, you're going to run into problems, like you say there, where you find multiple systems are iterating over things that they probably shouldn't be iterating over. There's a certain element of, you'll see team being pulled up a lot anyway, which means it's more likely to stay in cache the more it gets used. But yeah, it is I suppose a concern of sorts. But I think that from my experience, if you keep your components small and your system small, then you end up with an architecture where it avoids the over it's like a wasteful approach. If your systems and components are not sized well against each other, then I think you're going to run into a lot of issues. So the key here is one of the reasons why I keep the components really, really small, is to minimize cache issues like that. Because if, for example, that unit team was actually a unit component that was just everything that was in a unit, all my random accesses are all going to be cache misses. It's going to be terrible for performance. But at least with that, I'm minimizing the cache misses. I'm increasing the chance that something's going to be in the cache. And also, because all the memory is close together, even if I have to go to memory, because it's close, it's faster for the memory to get. The further data is from each other on your memory system, the longer it takes for your system memory to get it for you. As if it has to cross, because it's built up of rows and segments. And if you look at memory performance, you'll get loads of numbers, and it's about the number of cycles it takes to shut down a bank and power up a new one, or shut down a row, power up a new one, and stuff like that. So, but no matter.
I will want to, if you have some references about this stuff, then I would love to read, because of course, like it makes sense, like the cache lines and so on, after it goes through the TLB and stuff like this, right? It can be in random places in physical memory anyway, because the operating system can really map it at a bunch of different places. So like I would really love to see some latency numbers in comparison to the like physical memory location, because I haven't heard this one.
Yeah, okay. So so OS is distribute memory in pages. So that's going to be 4K blocks. Now, what happens, so this is my knowledge of Linux, so it assigns blocks. So if you were to if you request a larger amount of memory in one go, the operating system will do its best to have a consecutive line of physical blocks that can meet that request. Doesn't guarantee that it will, but if you just request lots of little bits of memory, your memory is going to be it's going to high risk that it's going to be all over the physical. But if you as what ENTT does is it makes one big request. So for each component, by default, it will say, well, your component's 4 bytes. So I'm going to request enough space for 1,000 of them. So it actually asks for 4K. 4K happens to be a page of memory anyway in the operating system. But if you've got slightly bigger components, then it'll have like 2 pages and stuff like that. So it will try to keep those generally together so that they sit physically close together.
I think that this makes sense, right? I think that the only part I haven't heard about is that memory, like actually, like when you go out of the system, right? The latency for access depends on where the previous access were. On
right,
the actual
yes.
memory. Like ignoring caches, ignoring prefetching, ignoring TLBs, like ignoring all of that. Like actually go to the memory controller. This is the first time we hear about first time. But anyway, I'm doing the off topic now, so let's just maybe.
Okay, I'll see if I can bring up something. Because I remember I'll see if I can find. There used to be some pretty detailed articles about how computer memory works, because it goes rows, banks, and stuff like that. Yeah, so that that'll be interesting. Okay, so let's have proceeding on quickly. So in terms of how do systems interact with systems, because generally they're not allowed to interact directly with each other, and things aren't really supposed to interact directly with systems. And you may have common code to do things that you're going to use in multiple places, but you don't want to obviously write multiple times. Well, I've created a section called utilities. So in utils, which handle all the stuff that doesn't fall within the purview of a system. And that's, for example, where the system management comes from. So when I create a system, actually in here we actually add the list of systems that we need to initialize in there. So the engine can call this to do an on update, on preload and stuff like that. That's quite a simple one. Global utils, let's try build utilities. So some of this stuff might be here just because we're interacting with the existing Spring system, but generally if you want to add, say this unit is a builder, it will basically go through and do the arbitrary one-off thing of setting up that entity to become a builder as far as the flow, the ECS system is concerned. So what I've done is I've added something called an entity reference to units, which is just the entity ID, which I can then use with the entity system. So I can now set up components. So this in place or replace basically means insert this component or replace it if it doesn't already exist. So we've got things like build speed, which I can calculate. It gets put in, repair speed and stuff like that. So all the things that we need to handle building. So that's how you sort of like add a component. You can just do in place if you know it's definitely not there. I don't know where all the calls are going to come from here, so I have to do build or replace just to be on the safe side. When you say, right, I'm now building something, you can set a build target. This slightly messy code at the top there is just really sort of validation and checking what's going on there, just making sure things are that we can actually do something. Try get some way of finding out whether you've actually got that component on the entity. Optionally pulls that out, which will be a pointer. So we can say if it comes back null, that entity doesn't have a build speed, so we can't build anything. So, all right, what are you doing? And that's interesting because that is, yeah, so it's got the return there, so that's fine. So it won't do it. So it pulls out the build power, sets up. So I set up an active build component to say we're now actively trying to build something. So we've got the entity that we're trying to build and the build power for that, and that's all stored in this one component, which is just these two elements here. And what will happen is that the build system, I'll look at the build system. The build system actually picks up. So it will look at build. So it's got two stages. One, it will take a look at everything that's got an active build, but doesn't have any allocated resources. So it's another one of these. I basically look at the list of stuff and go through the list partially. So right, everything that doesn't actually have resources allocated, but the build is active. This part will pull out the details of build power. It will reach across to the build target. So in the build details, so we've got the build target. So I can now, even though I'm iterating through the builders, I can reach out to other entities by using registry get, which allows you to reach out to absolutely anything at any time. So okay, I need to get the build cost, I need to get the build time to calculate the build step, so that I can work out what my resource request is. And then I can set up a resource use, which, as you saw in the flow economy, it reads that and does allocation according to that. And it will give me an allocated unused resource component when it's assigned me some resources, which will then we've got this other loop that immediately runs afterwards, which basically goes through everything else in the active build that has an allocated unused resource. And then what we basically do is we use that to actually progress the build. So this is basically pulling out details into local variables. Quick check to make sure we can actually build. If build power 0, it means it's been paused. And if it's been paused, we just say, well, we remove the request, because there's no point requesting resources if we're not actively applying them. If we are doing some build, again, we consult various, we ask the build target about its current status and stuff like that, its health, its build progress and all that. And then we build up this build step to work out how much progress we can make. And then there's this little bit of logic just in case that we're overshooting because we've already built it. So this is where I actually do the recalculate how much we've used of resources, so that when this gets deleted, which I've set up a scoped exit on that resource, so each time I go through a loop, I'm clearing out those. And then there's this bit here which actually shows an interaction between two systems. So if you finish building, but the unit's health is not full, then in Spring Engine, the builder automatically goes into repair. So what we do is we pull out the repair speed of the entity that was doing the building, and then we set up an active repair component on that entity. Say, this build target, you're now repairing it, and this is how much power you're applying. And then we get rid of this active build component because we're no longer actively building, which means this system will no longer see and process this entity, but the repair system will. And the repair system's over here. So active repair. If I go to so again, it's got a request resources, so it looks at active repair. And looks at anything that hasn't got an allocated resource usage, and it works out how much it's going to cost to do a repair, because it can cost, it might not cost. I think in bar, I'm trying to remember if there's a cost to repair. I don't think there is. Some games do, some games don't, but the engine supports it, so I have to as well. And everything that's been allocated, all repair jobs that have been allocated resources by the flow economy system can now just get on and do the repair logic again with pulling down values, early check there, pulling down more values, doing the calculations, checking if it's overspent, or is it ref usage? Yeah, if it's overspent, return excess resources, and then once it's finished the job, saying, okay, well, the job's done, it removes the active repair component, removes the resource request. So the flow economy system and the repair system no longer no longer see that entity. So I'll just quickly show the save system for you, so you can just sort of see what's going on there, because this is actually very, very swish, I think. So with this, with these sort of everything that we want, every component that we want to save needs a serialize function. So I've created some generic ones, so that if you use some of my templates and stuff to build components, then they'll automatically have the appropriate serialize command for them. But all it is, it's just a function that we're using. I'm trying to remember what it's called. It's called serial. So Entity is specifically designed to work with a serialization library called serial. Serial is very lightweight, it's header only, and it's very performant, and it outperforms Boost in terms of the data storage size and the speed at which it works, apparently. And becomes very highly recommended by everyone in Entity, and they just absolutely love it. So, and it works seamlessly. But the idea is that it provides an archiver, and you just call the archiver with your appropriate values, and it just does the magic. And this will work this will work both ways. So this handles serialize and deserialize just in that one function. So anytime we add a new namespace for components, because if we converted Spring over to doing ECS, just the simulation itself will result in several hundred systems. I project easily 300 to 500 systems. And if we were to do the whole simulation, all the bits that were logical to be converted, and we will have thousands of components. So to make that manageable, I've obviously grouped components into headers, which have namespaces like build, environment, economy, flow economy, and that. And each of these has a serialize function where basically I just put a list of all the components that need to be serialized. So if you add a component into a namespace and it needs to be serialized, just add it to this list in the serialized components function, and it will be saved and loaded automatically whenever you do a save or load. And if you add a new namespace, then just add the serialize function from the namespace into this function, and it will now be automatically saved and loaded. And the rest of that is just the setup, debug stuff there. But yeah, that just handles saving and loading. And it is just, really, really simple in my view, and easier to get my head around than the CReg system. And the other advantage is that it has no impact on performance during runtime. Because CReg system, when you add entities and remove entities, I believe it has to keep track of it all. Whereas with this, it doesn't care. When you hit save, it will then go through all the components and save all the ones that need to be saved. Otherwise, you add remove components, and that does not matter. It has zero impact on performance. So that one I was particularly happy with, the saving and loading capability that Entity produced. Okay, I'll just double check my notes whether there's any other major things to bring up. Just very quickly about lists in components. Obviously, we don't want, if anything goes into the entities in ECS system, you don't want to start introducing dynamic lists outside the ECS, because that's obviously potential issues with performance that could introduce. So there's two ways of going about it. One way I'll show you here in, I think it's essentially the flow economy here. If we look at a resource pack, you'll notice that the resource pack is in essence a fixed array. Could be a standard array for all that it matters, but array like that or a standard array. That's one way of doing it, so that every component has a fixed size. That's great if you know what your limits are and the variation in how many entities, how many elements you need in that array don't vary too much. If you need something more dynamic, then the suggestion is to use what we call a dynamically linked list. And I got example of that in the flow economy in form of economy tasks. So as I said, that each little thing that can be doing adding or removing, you can potentially have about 4 or 5 of these things on an entity in the engine. And in fact, you can end up spawning more, because if you do really stupid things with the with setting up the variables, I have to create additional unit economy tasks to get the same sort of behavior. So it's like, don't do stupid things in your economy values. But I know there's reasons why they have been done in the past, and hopefully we'll get rid of those. Like solar panels have negative energy use or something like that. to generate energy, it's really weird. Rather than gain 20 energy, it has negative energy, negative 20 energy use for some. There's a weird reason for it. So if I look at an example of doing this, we've got that's we need. Okay, so I've got this structure, which I'll try and get it more standardized. A chain entity, so that would have a previous and next reference there. So you would put that on your component, and it will tell you the reference to the previous entity in the linked list, the next entity in a linked list, as you would expect. And then I think that might be all that you need, but the unit itself, try get chain entity, creates a chain entity. Oh, right, yeah. So, and then each economy task obviously needs to know what its owning entity is. So that's just simply a single value for entity, which obviously points back to the unit that owns that economy task. So from any economy task, you can always go back to the unit that owned it. The doubly linked list. I've got shorthands for removing from chains, adding to chains, and stuff like that. And it actually turned out to be quite simple to iterate through linked lists. I think I've got, if I look at units, so this is where things may show a little bit of potential. Clean. I jump down to here somewhere. I think, yeah, here we are. Deactivate. So cool. So okay, I've set up a utility called iterate all unit economy tasks, and the purpose of this is basically to go through them and remove any of the tasks that are marked as a conditional economy task. So in this case, it's when you deactivate the unit. So some of the economy tasks always run even when the unit's deactivated. Some of them are, you can activate, deactivate. So when you deactivate a unit, I just have this this loop that goes through and says, right, is it a conditional economy task? If so, I just delete it. When you reactivate, I'll just add them again. It's fine. It's not a problem. It's just it's quite cheap to do in flow economy. So if I have a quick look at the underlying code there for the iteration, it picks up the units chain entity, so that's the head of the chain, and then it just runs through essentially each element in the chain and applies should apply the function that you passed in. Yeah, there you go. So basically it just calls the function on there. Just keeping track of the next unit in the chain, just in case you try to delete it. It keeps this so you can track what's going on. But when you delete elements from chains, then this obviously reconnects the chains as necessary with the delete there. So that's just like the usual thing. Oh yeah, so put into the functions there, disconnect from chain. Oh my god. Yeah, get previous, make it the next, and get the next to make it and add it to the previous. That's just pretty standard, and that's how dynamic lists need to be handled in an ECS system. So as your options, you either have a fixed array or you have doubly linked lists. And if you want to see what some of the pain that the engine causes me, when you create an economy task, so if there's these rules where if you've got, say, the prorated economy rate, if you can use energy and it can be greater than 0 or less than 0, and you can have added energy, and there's a condition where if you can't use your energy, you can't add your energy. and crazy things like that. So, and because you can do the invert where you can have negative use energy, which actually adds, and that's an unconditional add, it will always then trigger the add from the add if you've also got it. So it's like, God, that's just causes my brain to melt slightly. So this is all the so I have to actually build this logic here, and I've put it in the unit CPP because I hope one day you could just get rid of it. But that's all it's doing. It's just setting up potentially multiple economy tasks so that the flow economy, everything else can just run elegantly and smoothly. And this only ever happens when you actually have to add a task or remove a task. So it will be, for most units, it will happen when the unit's created, and they'll be removed when the unit's deleted. So yes, so working with the Spring engine, we may see we'll have to create some intermediate code to handle some of the crazy stuff. A lot of the delicate stuff that I had to do with this was related to yes, weird behavior in the engine. I had to really think about how do we work this. So there's a lot of stuff code in the flow economy. Sorry, in the ECS stuff that I've got. I'll see if I can find. Yeah, and one of the other consequences is that I have to remove stuff from the C++ code, the existing C++. So build speed won't be there anymore. It now is all. I might be able to find it by doing search. Essentially, here we go. So where you do calls like that, I now have to switch them out for that. And the main reason is that trying to keep both the build speed on the entity, in the unit, in the old style of the engine, and to keep a component, that's got a wrapper. I went through a phase of thinking maybe I should do wrappers rather than write that out in the code, but I'm second thoughts about that. It just like it's very error prone. It makes sense for me to essentially remove that, see where all the code goes, can't find build speed, and then replace it for things like this, so that I know everything's now connected and I haven't missed anything. And then in future maintenance and that, we could basically just keep up with it. And everything needs, if we're going to go ECS, then everything needs to move over to that anyway. Potential impact on performance might be some. There's always that potential concern. Let's say object-oriented programming naturally is just reaching out into semi-random areas of memory all the time anyway. So arbitrarily reaching out to a component like this probably isn't going to be that much different. But the idea is that they're probably, I'd imagine that we maybe find cases where things will start running a little bit slower in that respect. But if we push for ECS as the way forward, then we would want to actively convert more and more of the engine so that the parts that are benefiting from the ECS improvements outweigh the parts that are potentially having at least some impact because of the ECS system. But it's but my feelings are that just going through this builder stuff here, look at this could quite easily turn out to be half a dozen systems just in the builder code here, and then you've got unit, which will probably turn into a dozen systems, and then you start going through other things than that. And I think to go through all the debugging, and the architectural conversion that you have to do carefully, I I would estimate an average of probably 1 week per system of volunteers' time to basically do the conversion. And as I say, there's probably, as a finger in the air estimate based on what I've seen so far, there's probably going to be somewhere, if we were to convert all the relevant parts of SIM, probably between 300 to 500 systems. If we were to do the whole lot, how much we'd have to do before we've hit that point where it's definitely better across the board regardless, I don't know, maybe 60, 80 systems. Carefully targeted at the areas that need it the most. For example, the movement code. I must admit, I'm on the fence about whether, you know, the it's about bringing the ECS to Spring. I can see the benefits of it. You know, if nothing else, that there's the potential. If we look at the structure of the code, you know, you've got your systems here in one place. You know, you've got your components listed out. You've got utilities. It's kind of quite clean in that respect. There's also, do it right, there'll be good performance gains for this. My concerns are that we might be there might be areas where we're fighting against the engine because the engine is very heavily developed in one particular direction and angle. For example, as I said, the slow update doesn't translate over to ECS. Not very well at all. There's potentially other things that might have an awkward approximation that we'll run into. Since the flow economy system, the economy system is relatively simple, but even that had some ugly areas to it, like as I've shown with just trying to convert values into sensible, well-structured, data-orientated data. It's like you saw that looked rather convoluted, but this is pretty convoluted stuff there. But the actual code, let's see if I can jump to it. The actual here we go. But the logic in C++, but a lot of it is kind of just this bit here. And a lot of that crazy logic is just by the consequence of the order in which these things are done, or whether it's in an if statement or something. There's so many implied behaviorisms that a lot of it is completely accidental, which is perhaps seen as a downside. But because it's now in the engine, you now have that problem where you would have to convert it into a data-orientated approach. And when you convert it into a data, it's like, this is all crazy. And here's an example of how long some of these lines can be when you're trying to extract data from the ECS, and there isn't really an easy way to simplify that by enough to make it worth by going through the process of trying to simplify it.
Yeah, it's just boilerplate. There's nothing wrong with that. C is boilerplate heavy anyway. Do you mind if I have 3 questions I've collected over here. The first and the simplest one is rather specific about does this kind of flow economy system support priorities?
At the moment, I haven't done any prioritization in it. It follows a completely fair system relative to the amount of draw that each task is attempting to draw. So if something is drawing 100 units and something's drawing 50 units and your proration rate is 50%, then the thing that's drawing 50 will draw 25 and the thing that's drawing 100 only draws 50. But I suppose there's nothing in theory to stop the current stop you from making use of prioritization in Lua level at the moment. I think that would still work because it's just a case of you just, as your economy falls to a particular level, you just switch off certain tasks.
Yeah.
And if you switch them off,
That's one of the nastiest gadgets in the game,
Yeah.
by the way. Flores rewrote it a while ago to make it a little bit less nasty, but it is one of the really really horrible parts of the game code is because it's done on all Lua, so it's actually
Yeah.
really slow, even still.
So my thought was that you had that priority system as a way of just trying to make the economy manageable when you're basically not got enough resources to meet demand.
Which should be, from a competitive player's perspective, should be all the time.
So
Your
to
ideal
me,
state is to be on
yeah,
zero metal.
yeah, to basically be spending your metal but max energy. Now with the flow economy system, it's prorating across all your tasks all the time. So you don't ever have a situation where a task is staffed where it never makes progress.
Ah, yes,
Like
that is
in
definitely
bar
true.
at the moment, the problem that you got that I thought the prioritization system tried to sort out was, hopefully trying to get it so that, if you've got things, it still falls foul of it where things can still be cut off. So one factory's producing 20 units a minute, and this one's producing only 10. There's no difference between what they're doing. It's just that unfortunately, because where they sit in the slow update process, one of them's getting access to more of the resources that it needs more often than the other one, which kind of gets the sloppy seconds, so to
Yeah,
speak, of what's
that's
left.
completely broken, but the fact that we do kind of need a way to assign at least a high and a low priority level to all of this construction, because I don't know about the others, but I use priority extremely extensively due to the fact that I know that the proration is a little bit broken. But for example, like just the simplest gameplay example, I usually put my first lab on low priority and all the constructors assisting it on low priority as well. And so that way my commander will always have high priority because that's the default. High
Okay.
priority is the default for nanos. Low priority is the default, which is also sensible because you're going to overbuild nanos anyway.
So there's absolutely no reason why we couldn't add a priority system into
But
that
that doesn't
ECS.
require
And
adding like I don't know, running through the units twice, saying, oh well, first I'm going to run through all the high priority stuff and have them take all the resources they can get and then divvy up the
no,
rest.
what you would do, because it would be based on, you'd probably do it based on, let's think about it. So you would tag units with a priority tag, like this is low priority. So if you could have a system where it detects whether it's because I suppose the priority is that the high priority stuff gets its stuff first, and then the low priority stuff gets its stuff if there's anything left. Yeah, there could be ways of doing it. I'm just trying to think about how it could be. There are various things that we could do.
Because one of the reasons
To
why that gadget
just
is so slow is because there are a lot of assumptions being made in order to make it even reasonably performant. There's a lot of simplifications, gross oversimplifications in that gadget to make it even somewhat sane.
Yeah.
Computational
So
aspect.
there will always be you introduce, say, if you want a priority system, there will be some cost to doing that. Because you're introducing additional logic complexity. Now it could be that it might need to be built into the flow economy itself, or it could be split out as a system depending on the approach taken and the needs of that system. I'll probably have to explore it in more detail to do that. I was kind of going back by my experience with TA-based more Supreme Commander and Ashes of the Singularity, where they don't have this priority system, and what experienced players do is they monitor everything they're doing. They're sort of monitoring their economy, and if they got workers and things, they just shift the workers to whichever jobs they need with the more work. And it's like, okay, I'm building, okay, I've absolutely correct. And they try not to get into a situation where they've crashed the economy. Okay, if they get an area wiped out and they lose a load of mexes and things, it's like, well, I'm just going to have to cancel some jobs and stuff and balance the economy, because the idea was that you focus on the jobs that need to be done, and you should be managing those jobs directly rather than implicitly. Now, obviously, it's a different philosophy then, but I can appreciate that players got used to doing things with the priority and like the convenience of what it sets up. So that is a very good,
The problem with
very good
not
point.
having it engine side is it becomes then advantageous to write a widget to do so, which
Yeah.
will result in, first off, it's not nice to force players to have a different widget, and widgets will increase all communication overhead and everything because
Yeah.
it's going to spam commands.
It could definitely be added, and it will definitely be much faster, and putting it in an ECS, regardless of how you have to iterate, will be blisteringly fast in comparison to other approaches to implement that. So yes, it could definitely be done. So
that sounds absolutely amazing. By the way, the ECS, I'm completely sold on it, and I think that it's an excellent way of approaching where there's no real improvements in single core performance anymore. For the past decade, we could safely say it maybe has doubled in the last decade, but that's about it. Compared to everything, there's always more cores available, and this is just the absolute general perfect way forward.
yeah, but in fact, perhaps more important than single core performance is memory performance has been progressing even slower.
Oh, right.
Yeah, so that's the argument, that it's the memory performance that's the issue, because quite a lot of things you can throw, many problems you can throw extra cores at. Although the more cores you add, the fewer problems that can be solved that way, but still CPU IPCs improved and stuff like that. So, but memory has been unable to keep up, and has been is just the gap between what you can achieve with a processor now and what could be done with a memory. If you look back at even like the 386 and memory for the 386, the difference in performance, if you looked at the gap, it'd be really small between the 386 and its memory. But if you look now, it's a massive gorge, and it's only getting bigger. So yeah, and from early analysis that I did with help from Ivan and I can't remember, someone else ran some tests for me on Linux, and we caught some preliminary level 3 cache miss data, and doing some sort of finger in the air, taking rough estimates based on what we know about cache misses and stuff like that. When in the heaviest tests that we run, which is like the fighter test, with however many arm balls or whatever blasting at each other randomly, we were finding that the cache misses happening because of the way that Spring's been architected was causing the CPU to essentially be sitting, doing nothing but waiting for system memory for anywhere between 28 to 28 to, just trying to remember what the figure was, nearly 50% of the time.
Whoa, that's crazy.
It is absolutely insane just how much we are, because of the object-oriented programming approach that we're using, we are absolutely hammering the memory bandwidth on there. It might be that just get the latest Ryzen 12 or whatever it is, like 200 megabytes of cache, and it might be that it's suitably big enough that it contains all our simulation, enough of our simulation data to make it all go away. But obviously we want to support we want to support old machines, and that's kind of what a lot of people come to bar playing. So we want to make sure that those machines can still be as performant as possible, so they can enjoy as many games. I've got
to bounce in a moment, but I want to say it's been a fantastic explanation, and I'm all for it.
Oh wow. So the Beharif, in terms of you're happy with the impacts of that introducing the ECS to Spring will essentially entail is that I think it's going to be the trigger of essentially the rock slide of we go down this route, we got to keep going, and we're going to have to actively be spending effort in converting more and more of the engine into ECS, obviously targeting the heaviest areas first. And this isn't. It was kind of strange that my feeling, once I'd been working with this ECS for several months, I went to go and do that, that multi-threading in the collision code.
Yeah.
Which has a whole load of potential desync risks and stuff like that. And it's like trying to multi-thread that crazy code. I found that a walk in the park in comparison to what I was doing with ECS.
Really?
I don't know why. I think it's possibly because part of the pain is trying to translate from an object-oriented design to the data-oriented design of the ECS. It's lovely once it goes in, but it is such. I found it actually quite a headache. That it's like, okay, I think I've got it sussed, and then you find something in the engine code. It's like, what the fuck is that doing in there now? I've got to rewrite the bloody system because that changes everything.
Yeah, I had this very similar. I still have this very similar experience when I try to rewrite the simplest draw stuff to be, well, as you say, data-driven. Just submit once.
Yeah.
And then see all the bugs crop up. That God, this can't be true.
So it's just that obviously that's going to just happen all the time with this. I don't know how many people are going to be wanting to dive in and help with that. I'm trying to make this as easy to use entity as possible. Entity itself, trying to understand how to do things with it is not simple. It's so well written in template code that you actually need to be an expert in templates to actually know how to use ECS properly, entity properly. But once you've got some good working examples, like what I've tried to do there, then it's actually very, very simple. So, all right, I just do this, but there is so much you can do with entity, and it's changing all the time. Because the guy works on it full time for Minecraft, adding features to it.
I think it's wonderful, and we should absolutely go forward with it. Now, I have a problem where if I hear the word template or auto, my brain just throws a. It's like throwing a spanner in the works. But I've gotten through worse.
Yeah. Well, this is a template. This right here is a template. Yeah. The beauty is that once you've worked out the patterns, you don't need to know what the template does. It's just you just do a get. It's like a function. You just remember that rather than put that in the curly brackets, the round brackets, you put your entity, you put your component in the triangular brackets.
That works.
The fact that it's the basics of entity is like, oh, it's a template. Well, who cares? Because I just use it. But some of the stuff I've been doing with
to know that.
Some of the stuff I'm doing with the groups to get performance and that does require some understanding underneath the hood too, because if you're not the thing with entity is that if you're not careful, and if, for example, you do an in place to put a new component against an entity, but if that entity is already there, you can very subtly break the registry. And I've had some weird little problems with save loads where I accidentally did something and it caused, I was adding components, and because I was listening, because I had a system that was listening for components, so when you add a resource use component, there's a listener in one of these that goes, where is it? think is it utilities? No. Units utils should be a unit. There we are. Unit economy utils. Let's just get the snapshot. Yeah. So get current snapshot. Gets the usage. Adds that up. Yeah. So one of the things I do with the snapshot usage, which I think is an improvement over the engine, is it actually does a buffer. So because it takes it every half second, I think in the engine it can double up costs. So I have a feeling that if you use the command as dgun, it incorrectly reports you using 1,000 energy for half a second rather than 500, because it says, well, this is what I've recorded for half a second, so you obviously have to multiply it by 2.
Yeah.
A one-off cost. So I've buffered it so it switches between the buffers, so it's always got the last half second plus what you get for this half second, so it gets added together and reported. So I put utilities around that. Okay, it's the actual system itself that does the listening. Oh yeah, the unit economy report system. So the purpose of this system is it keeps track of your resource usage and creates a snapshot. So every time you use resource, that gets recorded in the current, so there's resource current make, resource current usage. And what we do is we create a snapshot of that, so that it gets reported back to Lua. But yeah, I've got these connections. So if you try adding resources, so yeah, if you do a resource add, so registry on construct resource add, so any entity that gets the resource add, we call this function. And what it does is it adds another component so that we can track your usage.
Mm-hmm.
So resource add is like, well, we now track that automatically. So you don't have to think about that. That's really cool. But when I was saving loading, the order in which the components got added triggered this on construct. So it added this component, and then the save system also added the component. And then when I ran through the groups, everything got counted twice for some inexplicable reason.
Mm-hmm.
Even though it was the same component, it got counted twice. That was quite funny. But yeah, if you're not careful and with things like that, you can end up causing it's mostly the groups that are very, very sensitive to things like that. But okay, yeah. So you're in
can I have
support?
another question?
Yeah, sure.
So how does this work with allow unit build step and allow feature build step call-ins?
Right. Okay. So first question is, do we actually make use of that?
Let me do a quick check. Wait, no, I'm streaming at the moment. As far as I know that we use both of them, but mostly for some prevention of some weird hacks.
All right.
I
Okay.
think Flores knows more about allow unit build step and allow feature build step. And I know that those two are extremely heavy. And I also know that, that ZK uses those pretty extensively because they support stuff like reverse build.
Reverse build.
Yeah, you can build something. Yeah, when you reclaim something, a building in ZK, it gets built in reverse. So instead of
Rather
getting a
than
lump
just gets
sum, it gets turned back into a nanoframe. But this might not be true. There's no one from ZK here. Maybe Ivan D is the one who's most familiar with that. But yeah, I know that they use reverse build, where I think the allow unit build step is going to return a negative value for the step size. Anyhow, so
well,
we can probably do without it.
I haven't put it in, and I didn't run into any problems with bar. without it. So, but that doesn't.
Okay.
But I haven't tested it extensively enough. It's like I've just built solar panels and wind panels and energy converters and stuff like that. I haven't exactly done a big game, pushing it to its limits and see if there's any issues. I didn't run into any issues that I could see, either because I've inadvertently worked around any problems that you guys had, or maybe the natural state of the flow economy and the way it works maybe has solved that problem, but or I just haven't run into it yet.
Yeah,
But we
one
could add
biggie
in.
is capture. Is capture handled by the ECS?
I haven't converted that system yet. I ran out of mana after doing repair, because
Oh,
then
okay.
there's
Yeah, repair is
resurrect, there's
really hard.
capture,
Yeah,
um,
because
and then
capture
all
becomes
these
really horrible
problems.
when the capture finishes, and then that triggers a huge chain of events. Anytime a capture is completes, it's it's a nightmare because depending on who sees what, at least on the widget side where I have the most experience, like when a capture
Okay.
completes and a unit gets transferred from one team to the other team, that is when a whole host of call-ins are spammed and a lot of the game state changes. So
All right.
like doing the capture in like yeah, because you're reading the unit's team in every system, that should be fine because you wouldn't want to. Let's say you've captured something, and then that like there was this exploit where you could give metal makers to someone to make them stall. Back before metal makers were automatically managed to be on and off. I mean, by a gadget. They wouldn't be managed, and
No.
that was an interesting exploit where you could give someone metal makers to stall them out for just a second before they noticed. When you were mounting an attack, so make other lasers not fire because you've given them metal makers.
Mm,
So there's just a lot of side
mm,
issues regarding
yeah.
that stuff.
Um,
I'm
so
very
this.
happy to help test this stuff
Mm.
and fix it
So
all.
I don't think there's anything that we couldn't do. It's more of a case of working out how's the best way to translate that into a data orientated design. So that might be the the pain point. Saying was all
Yeah.
this, but obviously I haven't got calls to the build step in here, but there's no reason why I can't put it in. As
I'll run through our
it's a
code
cool.
and I'll get back to you on that. And if we
Mm.
use it for anything sane.
Yeah,
We
like.
just use it to fight the bad proration.
Mm. Well, yeah, and also you got your request for priorities. It's like we can work that in. It's really just a case of, well, what's the best way of, do I build it into the existing flow economy, or is that better split out into a separate system? Yeah, I think these are, even things like, these are simple little things, which I suppose in object-oriented programming we're so used to it. Was like, oh, we'll just bash that out, and it's just what it is. There's usually only really one sensible way of doing it, and it costs whatever it costs performance-wise for it. And for this, I think a little bit more, and it take a bit longer to figure out.
It needs
Um,
heavy thought, definitely.
yeah, so that's even for something small and simple. So. So my concern I guess part of my concern is just the human factor in this. If this was like brand new greenfield engine and we
Yeah,
got a sort of
it'll
our
be
requirements
easy
and
mode.
things, yeah, that we I think would have no problem. It would not be it wouldn't be a question of whether
Yeah.
you use the ECS or not. And we just do it, and it probably wouldn't even need as much thinking about either. Trying to interact with an existing simple system. I've got quite a bit of code there, but the amount of code I've actually replaced in the Spring engine is a tiny fraction, and that was the thing that was a little bit demoralizing for me, in that the bit that I replaced, I've probably, the hundreds and hundreds of lines of code that have gone into setting up the systems and all that I've only replaced like 30 lines of code in the Spring engine.
Yeah, but it was implementing all of the framework, and adding ENTT was
Well,
pain.
yes, there is an element of that. Even a simple system will be about 50 lines. That's just like run
That's fine.
through
It
and
is what it
add
is.
two things together. So yeah, it's really sort of the time aspect to it, when we can get something suitably
So this isn't in
meaningful
the
together.
master bar branch. Yeah, it's only in the ECS experiment branch for now.
It's in the experiment branch. It has to be in the experiment branch because I've got changes that go through the engine. Like I actually switch over to we saw earlier that some of the components had actually been switched out and into the system, and some of the Lua calls now are actually picking up their values from the ECS, not.
Ooh, that's
So,
nice.
for example, I wish I could actually fire this up and show, but I haven't actually got it built at the moment. One of the things that I did do in my flow economy was to try and smooth out the bars that show your economy. And so, if you manage to get everything into flow economy, the flow economy is updating at 10 frames per second, and your energy bars at the top, or your resource bars, will now flow back and forth as they should, rather than stutter about, which they currently do
Yeah,
in Spring.
it's not an easy
So
one.
they look quite good. I've had to put 10 hertz down for the flow economy, so it was updating frequently enough not to look too jarring.
Oh, that's perfectly fine.
on the bar. Obviously, it could be lowered, bring back more performance, but you'd then want to have something that interpolated the changes in the bars or something like that. But that's probably not necessary at the moment. What was the other thing with it? Yes. So one of the things I thought of that might be worth considering is if you wanted the flow economy. Let's put the things in that you want for it, that you could also get. This could sit side by side with the flux economy, where it's just taking stuff as it currently does at the moment, because that is perfectly fine. It's just that flow economy takes its share before allowing anything else to take its share. But you could move all your laser towers, cloakers, and all that into flow economy as well. I thought about an implementation for that we could implement. And essentially what it would be is that each unit has you give it a storage. So a laser tower that uses 50 energy to fire would have a storage of 50. And you would set up a recharge rate, which would coincide with the reload rate of the laser, right? So when the laser is activated, it will immediately start to charge. So the flow economy will be flowing resources into it. Boop. And then when it hits 50 and it's got a target, it will shoot and spend that 50, which will automatically trigger the flow economy to start refilling.
Yeah,
And then each time it's refilled, it will fire. And what it means is, so if we go back to the example where your economy is being prorated at 50%, your laser turrets will fire at half rate because they're only because the way the proration works, but they're still firing, and they're firing at regular intervals. It's now, rather than once every second, it's now once every 2 seconds. So it's not managing your energy is still having a consequence, but the laser turrets are having a measurable performance that is kind of meaningful, may make things easier for balance, perhaps, because it's a
bit more
knowable.
Yeah,
and then
I've had thoughts of completely rewriting the priority system, but from a widget side, and the only reason I didn't do it was having to deal with the network overhead involved with it.
Yeah, so if you send me the requirements of what what priority system, because I don't use it to me, but if you send me the requirements of what a priority system should achieve, then we can basically build that into the ECS flow economy so that that can be met.
Charging lasers should be always the absolute highest priority under all circumstances. The only time when it maybe wouldn't is when you're trying to charge a D gun. But other than that, it really is a very fixed list of priorities, and it's quite static as well.
The D gun has got a special widget or something that works on it. When you try to use the D gun, it immediately seems to take over the economy.
Instructions.
And it continues to work like that even if you got flow economy switched on. So widgets seem to still be working.
Yeah, that's
and yeah, it's just for cloak and like shield-based units. What I would imagine they would do is obviously they would have their storage with a recharge rate, which would probably represent their normal drainage, how much they would drain when they're active. And the way I would see it is that they would charge up. Once they hit full charge, it switches on and it starts draining at its draining rate. But the flow economy is constantly putting energy in.
Yes,
and it's constantly taking energy. Now, if you start running out, you start prorating, it means it's not quite putting back everything that it's taking, and the storage is slowly being drained until it gets completely drained and the cloak has to switch off, whatever, or the shield has to switch off, at which point it then starts charging again, and only when it's fully charged can the cloak come back on again.
Mm-hmm.
So then that way it avoids any horrible, like, rapid flickers and crazy things like that.
That sounds good. Perfectly fine.
Okay, well.
Right. Does anyone else have any questions?
So regarding the charge rates, is it a fixed item or is it something that can be changed within the game as it goes on? That's
oh right, okay. So I was imagining it would be configured in the unit deaths. So when the unit's created, it has that property. But if you need to be able to dynamic, I'm not sure. I've never seen I don't think this is even supported in the Spring engine to be able to dynamically change values in the depth.
Completely. Anything that's units depth is static.
But in theory, if you had a case where you wanted to be able to change that dynamically, we could make that property available on a per unit basis so that you could write some Lua script to change it if you so wanted, though I can't imagine why you would want to.
I'm just thinking of a few cases. Thank you.
Okay. Yeah, I was going to ask Ivan if his views, but I think he's had to drop off.
Yeah.
So I'd like to get his opinion on all this.
Well, I'm pretty sure he'll watch the stream. I'll put it up on YouTube as unlisted for now, but you can share the links if you so desire. I'm not very good at managing YouTube-y stuff, so...
It's all right. This isn't going to be a terribly exciting video anyway.
I'll leave that to someone more capable.
For most people. Okay, so that sounds reasonable. I was trying to make sure I was giving this in a way that was
clear,
sort of impartial.
No, it was
like not trying to oversell this because cause obviously you need to know the downsides of this approach and don't want to misrepresent it.
No, the downsides are also clear, but they're nothing unmanageable in my opinion.
I think it would just be best to run a limited test with the system in matches just to see how things change up.
Oh yeah, the flow economy system is just, well, as far as I'm concerned, that's kind of like a, a package that just comes along because it was an experiment, and it just so happened that I just noticed how bad the economy was working in Spring Engine games and just had to do something about it while
Yeah, it's
while
the
working in that area.
ideal test horse for it.
Yeah, so it was a good test for this. I kind of regret doing it now, given that it was just something that seems so easy to begin with. It's like, I'll just put flow economy in, and then it's like, wow, this is. I've had to rewrite it several times.
Oh,
The flow economy approach, because I thought I'm using what we call proactive flow economy rather than a reactive one. Reactive is what you have to do in Spring, where you look at what was used and try and set proration rates and stuff for what's going to happen. You've got no idea what's going to happen, but you hope the usage records are close enough for you to just about manage it. Whereas proactive, everything gets managed properly, and you don't end up with things being starved randomly, but there's a small delay between trying to do something and actually doing it, because you have to go through a cycle to be allocated your resources. But we're talking about this running at 10 hertz, so that means 0 to 3 frames you will get you'll be able to do
that's less
your
than a
task.
network lag, so.
Yeah, and well, in the current system, it's all running on slow updates. So you tell a unit to do something, and it starts to build. It's got a delay of anywhere between 0 to 15 frames before it's actually doing it.
Oh, that's actually big.
Yeah.
So this
Yes.
this improves the command delay as well. Okay.
Well, we see is when you tell something to build, it usually has to move to the target, or it has to rotate or something. So that bit's still being handled by the engine, and I think that's run every frame regardless. It's more that when the unit gets to the point where it's pointing its nano turret at the target and says, spray it with some material, that's when you've got the delay comes in.
Mm-hmm.
Okay.
So yeah.
So that delay gets eliminated a bit or pushed down.
Yeah, so the start time may be slightly improved. Obviously, it really depends on what frame everything happens on. I think construction time is potentially slightly slowed because of the initial delay. So when the builder kicks off 0 to 15 frames later in the normal engine, it takes its full amount for that half second. And then every half second it's always taking that amount. With this, it's always taking its 10% of a second or whatever, but it will always have been that tiny fraction slightly behind. It doesn't say, oh, I didn't do anything for 0 to 3 frames, so I'm going to take the extra resources that would have normally been done during that time. So there's a tiny impact there.
So one thing I have to remind myself, or you should remind me to look at, is not only is how do we use allow feature build step and how ZK uses it, but also to see how their communism mode is done.
Oh yes, the build sharing, the sharing of resources and all that.
That happens, because it's also a non-trivial thing where I think their income is the income is generally shared for some factor of it.
It's
so
players. Yeah. I think it's the total max economy that's at the base value divided by the amount of players. Overcharge, I don't know if it adds metal to each player or if it's just to the single selfish player.
Yeah, I'll ask Google Frog and Sprung about that. They know pretty well.
Okay.
So impact on team sharing by the flow economy. If you are close to your max in terms of storage, what flow economy does is it adds up everything that's coming in, and it adds up everything that's going out, and it will basically subtract the two and all that, and then apply the difference to your resources. Whereas with spring, if you're close to your maximum resources and it decides by random chance it goes through 15 solar panels before it goes through anything that uses the energy, a whole load of energy ends up overflowing and will be prorated to the teams.
Yeah, I've
Which
seen
you
that, especially with
possibly, yeah, so you won't get that with flow economy. So if you get everything into a flow economy, you will not get that unnecessary excess. You might still get it, with if for each thing that's not in the flow economy, there's the flow economy will obviously add up all the economy all at once, all the income, and apply it. So it could, if you've got things that aren't in the flow economy that will be taking from there, it doesn't know how to take it into account. So that ends up being weighted as a result. So yeah, that might be a slight downside, but then moving everything to flow economy would solve that.
yeah.
And I can try and make it so it's like pretty painless to move things like laser turrets over, because if you were to just set the parameters in the unit def, then I can make it so that all you've got to do is just change the call where you try to use the energy to local rather than global. We could even do that behind the scenes if that was feasible.
The recharge idea that you outlined sounds the best. Absolutely.
Yeah, I was just thinking of trying to make it as easy to implement. So what you got to do is just set a couple of parameters, maybe change one line of code, and it's now there. And that unit's now sorted. You just go and do the other units, and they'll all start working that way. That's it.
Would it be easy to just set up a script to inject the data?
Yeah, Unit Post can do it.
You could do, but you might. Well, I suppose if there's an easy way to figure out what the values are, then yes, a script could.
Yeah, all the
you
weapons
probably could
have
actually.
the energy per shot definition specified.
And then you'd obviously, with your cloakers and your shield generators and things, how you're going to decide how much storage you want, because that will impact how long it will take before it actually goes online, and how long it stays offline when it runs out of energy.
Yeah.
But by having it bigger, it means that when your economy's being bad, it's holding out longer. So, maybe getting the balance right with that could be interesting. But yeah, so it's went on much longer than I thought it was going to.
It's quite a complex topic. So, and I think that if there are no questions left, not saying that there aren't any, just there's nothing specific. I see that Flores is also AFK. Then I want to thank you, TK, for doing this, because this sounds absolutely amazing and is something that's really going to take us forward a huge generation, and I'm extremely happy about it.
I would like to start playtesting with this.
I think well, in theory you could take the experiments and then start doing stuff. You'll probably find bugs and things in it that I've not yet been able to test. In terms of it being ready for a proper play test, I need to convert all the existing economy-based engine systems at least over, so that the only thing that's not in there will be like lasers and cloaks and stuff like that. It's just that obviously reses and reclaim and all that. I probably want to make sure that's converted over, so the main systems are in there, and that will probably take. Let's see. Well, my current projection could take, and then putting in the stuff that you want as well.
System, so far we're up to a dozen.
Yes, like a month and a half, yeah. And then tidy up and stuff for another 2 weeks or something. So and it's like, what, 2 months? So it's like all we've got is a a flow economy system that started back in February, and this is all we've got. This is all we're going to have to show for it.
Don't worry, I feel very similarly when I do a lot of this stuff.
Yeah.
Yeah, lights should have taken me 2 weeks to do. It's been 3 months.
Oh God, yeah. Well, yeah, the OpenGL4 stuff does relate very closely to this.
Absolutely.
I think in many ways it's
At
much
least
the same.
I'm so happy that my part is unsynced, though.
Oh, I don't know. I quite like the fact that my bit's synced, and there's quite a lot of it gets multi-threaded, and the challenge of that's actually quite interesting. I'm going to retract that comment when we find out that my new collision multi-threaded code has suddenly introduced a very subtle desync.
I've been stress testing that and found no issues with it.
Well, so far my testing methods have not failed me. So far we're using 2 machines.
I have
The only time it
here and it works.
is that with the latest from
Yeah.
oh, is it? So because that was the thing I wanted to test, because I made a few more changes to sort out performance, and needed to run some more tests
I'll
just in
update
case.
the engine for you because that one's not pushed out to the public testing host yet. Okay.
Yeah, I was probably just run them locally for me, but yeah, I had to fix a bug for 0K because some of the units weren't stopping when they were supposed to.
Yeah.
And unfortunately, you know about how going around loops is a bad, going around lists is a bad thing. Well, that's unfortunately what I had to do to fix the problem.
Oh.
Which has cost me some of my performance gain. I still gain overall, but I've managed to tweak things to mitigate most of what I lost out of that. There is something I can do to regain that fix and no longer need that extra
Extra loop.
Loop, but I would have to add a Lua call and and modify one line of code in 0K, because it's the what's happened is that when the unit reaches the destination, we mark it as arrived, but before we go to the updating commands, where there's a fallback that 0K uses to work out, it basically says, are you close enough to your destination? Okay, we've reached it. A whole load of collision can happen and push the unit far enough away that 0K thinks it hasn't reached its destination. So the unit it just keeps going. So if I put in a call to say, did the pathing system say we reached the destination, irrespective of whether we got pushed away from it, that would fix it. But at the moment, I have to do basically trigger all the Lua stuff before running the next set of collisions.
Yeah.
I've lost my commander to that bug. I have enough playtime experience to know what you're talking about.
Oh right. Yeah. Well, maybe this is a new version of that one. But I'm not going to put that I'm not going to put that alternative approach in by putting Lua call in yet, because I want to try and multi-thread the collision code itself. So everything leading up to the collision code is now, where possible, multi-threaded. So 1,000 fleas for me, I've got this horrible course I make them run that squishes them together and run against each other and stuff. And that now runs more or less sim speed, stays pretty much at 1 at full speed for it. Whereas, this is what I don't understand. When I first did this test, the sim speed dropped down to 0.3. I went,
wow.
Okay, we've got some things to do here. But for some reason, when I went back to 966 later, it didn't drop below about 0.6, that same test. And I'm sitting there scratching my head going, what? But it might be I was running it through a demo.
Or you're
and the
running
demo
debugger.
actually takes... No, it's not the debugger. It's weird. I don't know what that was. It's possible. I have to go back and double check. But I noticed that you get more performance when you run through the replay than you do when you're actually in the game. The sim speed is actually better from a replay. I'm hoping that's what that is, rather than, I don't know what happened with my testing. I know there's a certain amount of randomness and inconsistency, but
Oh, I
by
think I'll ping the
twice.
testers with that question. That's actually a good question. And it's
But I'll have to
something that
double check.
testers
But
can do.
either way, it is a significant improvement, even if it goes from 0.6 to 1 or
That's
0.3
already
to
huge.
1. I
'Cause it scales
recorded,
better.
yeah, 1,000 fleas were triggering over 6,000 collisions a frame.
Wow.
Oh dear.
That, yeah, and that means that 13,000 there's this check where you have to check the bounding box squares on the map to see whether you can go into something. The range check basically has to check every square, right? And when the code does a move, it checks that the unit can sit in that square fine. Now, that's obviously quite a heavy loop, and that if you have 6,000 collisions, that's 13,000 times it gets called that one frame.
It's huge.
It is absolutely huge. Thankfully, we've got a bug with units being able to push units. So if you get like a load of fleas around something like a sumo, you can get them to push the sumo, so the sumo
Faster.
actually runs as fast as a flea's target. And the reason for that is related.
I think
sorry,
Teddy
driver.
wrote a widget for that to exploit that.
Yeah, and I've accidentally exploited that a few times.
And that's because every single collision that happens is resolved independently and can cause a move. And this is part of the thing I don't like about, with the object-oriented programming, is that you do these things logically and you run through loops, and it all, if you don't think about it, it just makes sense. Whereas you should only move things once per frame, so you apply all the forces and then it moves.
Yeah.
And that's what things like ECS force you into, because the systems run once per frame. So we'll probably get performance improvements from that. But the next thing I'll look at for the collision code is to fix the bug, which means that rather than 1,000 fleas causing 13,000 range checks, they will now, the idea is that they'll only cause either 1,000 or 2,000 range checks, depending on how I can sort the code out.
Okay.
Sweet.
I'm just going to start thinking about how to exploit that now.
Well, I'll go try and fix it as quickly as possible. And then I can multi-thread. Then I'll do it in a way that I should be able to multi-thread the collision code. So the idea is that that collision code should be. I'm hoping it will be about 4 times faster. So at the moment, the fleas collision code is taking up to 28% of my CPU, as recorded in Spring. Obviously, it's taking about 28% peak, which is a lot. So I'm hoping I can get that down to something like 9% with a series of changes that should be coming for that. So my hope is that by the end of that, I don't know if this will happen, but my hope is that we might be able to run 2,000 fleas
into each other
at full speed, into each other, which should mean, given that movement code is one of the biggest performance hits in the Spring engine, that might allow us to have more comfortable big games in the future.
Sounds
Hello.
awesome.
Hello.
Hey, Flores.
I've been listening. I have a question about maybe you guys have an idea when the next version of the engine will be loaded.
Oh, okay.
Probably.
So because, sorry, go for it.
No, go for it, DK.
I was to say, because me and Ivan, you probably saw the chat in the engine. Obviously, I observed that Taku wants to run a tournament within 2 weeks' time. I suggested that we wait until after that to push the engine out, because I don't want anything that could potentially destabilize
Fully agree.
the game.
Fully agree. that if we want to run a tourney end of August, then there's absolutely no point in swapping out an engine 2 weeks before it, or not even 2 weeks before it, more like 1 week before it, because there still needs to be quite a bit of testing and mop up
Yeah.
done on the previous one. There's no point. That's shooting ourselves in the foot.
All right.
Yeah.
I was
So
under the impression that there were only a few fixes maybe to need to be applied because you already were testing the engine a lot and it appears to be stable. But sure, we can wait.
well, sort of yes, but because a lot has changed, the level of testing going on at the moment isn't the same as it going out into the wild.
Yeah.
I
I don't want
with
to
all the
repeat the
players on
mistake.
it.
I've done that mistake of early engine releases too often, and I don't want to repeat that.
Yes, I think if we had like a general rule, I would say that if there's a tournament coming up, then an engine cannot be released within 2 weeks of that tournament. 3 weeks might be
I'd
okay.
sign that rule.
And I would probably ask that the bar game also isn't updated within 1 week of a tournament, except to fix high priority bugs.
Yep, that's the plan.
Because
That's
last
very
tournament,
sensible.
we were having changes. I think there was a change that had to
GL4
be.
was being added right in, and that was not a good idea. I'm sorry about that.
Well, I think that came in ahead of a little bit ahead of that. It was just taking time to work out the
It was
issues.
buggy.
But there were other changes going on even the day before, and probably even in the morning of the last tournament.
Yeah, we'll try to refrain from anything that touches balance and that's not a strict bug fix.
But I would say that maybe the bar team would like to have, when they're about to say, right, we're going to go into this lockdown where only high priority bugs go into the main line, they just create a feature branch or something where if they want to just keep moving forward, that there's just a temporary feature branch open where they just put all their changes that they can do and test out and whatnot, so they can still do development. As soon as the tournament's done, they can just flush that into master.
Yeah, that's
Well,
the good
I
approach.
I think a week is a little bit overkill. I think we need to round off all the work a few days before and then only do some fixes or small fixes and not introduce new features or balance changes or stuff. And it worked out in the past and I think it will work out again.
So, all right. So if you say you suggest something like 2 days before the tournament, only bug fixes go in.
I would leave it at 1 week in general for balance, and then after that, it's 2 days before any bug fixes. After that, no bug fixes get to go through as well.
Well, I think Floris was talking about things. Okay, so maybe balance changes, not within a week, or
that sounds fair.
But there's plenty of other things like UI bits and other things that need to happen. That it's like, we can do those closer to the time. But obviously, it's going to be risk assessing. It's like you don't want to introduce like a big GL4 thing 2 days before the tournament.
Absolutely not.
So okay.
I recall me pushing in Ryan's music and then hands off to make it work and fix bugs is like 30 minutes before Tony started. That was not a good idea. Yeah,
very, very stressful.
Yeah. All right.
Okay, now
it's always more complicated than you expect.
No, absolutely. No, that's pretty awesome. Okay.
Okay, so thank you, TK, for your time and especially for all this amazing work you've done on the ECS system with the ENTT.
No, it must be crazy.
It is amazing, and also I'd like to thank everyone for listening in. And I'm going to stop recording in this moment because I have to go, unfortunately. So if there are any questions remaining, then I think TK can still answer them. But I have to shut down the recording if I can find OBS.
Yeah, sure. Yeah,